Welcome back. This is LLM Zoomcamp, and in this series of videos, we are evaluating our RAG system, meaning that we want to have a way of evaluating all three steps in the RAG flow: search, prompt, and LLM in one go. And for that, we use different evaluation metrics. We already talked about cosine similarity, and this is what we talked about in this notebook. So we evaluated three models: GPT 3.5 Turbo, GPT 4o, and 4o Mini. Right, and our conclusion was that 4o Mini gives the best results when it comes to cosine similarity. So this is the model we want to use. Right. Another alternative approach could be, instead of using cosine similarity, we can just ask an LLM if what we have is actually good enough or not. So instead of using cosine similarity, we just ask LLM. So this is the original question. This is a generated question. So this is original answer, this is a generated question, and this is a generated answer. How good they are. And before recording this video, I asked GPT for a prompt. So this is the prompt I used to ask for a prompt. I say, you're a prompt engineer, expert, and we work on a RAG project. I want to use the LLM as a judge method for evaluating the quality of my RAG flow. I have a data set with FAQ. For each record, I generate multiple questions using an LLM. And now I want to use these questions to see if I can recover my original answer, right? And then I need help with two prompts. In the first case, I have all three. I have the original answer, I have a generated question, and I have the generated answer, right? And then in the second case, I only have the question and generated answer. And you might wonder, why do we need two cases? So in the first case, in case of offline evaluation, we have access to the original answer from which we generated the question. But also, we don't always have that. So for example, when we already start using the data in production, we still want our system in production and get traffic from users. We still want to be able to assess the quality of this and do this on the fly, and also display this, let's say, in our dashboard. And for that, we don't have the original answer, right? So we only have questions, and we can still use an LLM to judge how good the answers are. That's why we have the second one, right? We can compute both now on offline, but then for the second one, we can also use it online. So this was my prompt, and then it suggested two prompts. So this, you're an expert evaluator, so which I think is quite good. Oops. I accidentally pressed back. Anyways, it's quite good, but then at the end, this is how it asks to output it. I did not like it. That's why I asked it, let's make sure the output is in JSON format. So then we ask it to analyze, provide evaluation in JSON format. We'll probably need to tweak the prompts a little bit, so to make sure it actually returns JSON. Sometimes it will not, and we already have this experience when we generated our data, our ground truth data set, right? But here are the prompts, and I will simply copy these prompts. Prompt 1 template. It's kind of long, so oops, let me do it like this. So I want to see the entire thing. And then prompt 2 template. I'll copy it from here. Oops. Okay, here. Okay, so cool. So these are two prompt templates, and I don't want to now execute it for the entire ground truth dataset. Of course, it's possible to do it, but we will just need to wait too long, and then also, well, it's not as expensive with the new GPT 4o Mini model, but still, I don't feel like I want to do it for all the well, for all the data. So what I'm going to do is I'm going to sample 100 records, or maybe 200. Right. I also want to set seed to make sure the results are reproducible. Random state one. So now every time, let's have it like that. Actually, this is not what I wanted to sample, right? So this is no, this is correct. So now we have the answer from LLM, original answer, question. So this is what we need. I'll call it data frame sample. All right, so this is our sample. And I will turn it into dictionaries. Which I'll just call sample, right? And then now for each of these samples, sample will be, or record. For each of these sample, for each of these records, I want to use that prompt to to ask an LLM to judge the results. So I'll replace these variables answer LLM, generated answer, and then question, and the original answer is, this is how we call it, right? And I will also change it here. And I will remove question. It's not generated question. It's not necessarily generated question. It can be just question. Okay. So we have this template. Now from the template, I want to create a prompt. Format. Did I not update it? Error relevance. What? I don't understand what's happening. Okay, yeah, maybe this one, right? So we should do some sort of screening, perhaps. No, I will need to ask ChatGPT how to actually do this. So I asked ChatGPT, I described the problem, and said that this is the error I have, and then it suggested to use this syntax. Right, so let's use that, and let's see if it works. Okay, it does work. This is our prompt. So this is our prompt, right? Okay, and now let's use we have LLM function, right? Which only takes prompt, and model will be, in our case, GPT for all mini. Okay, so it looks parsable. So now, if do I have JSON imported? Import JSON, and then so answer JSON load as answer. Okay, so the generate answer directly addresses the question. So now we will do this for all the records in the sample, and for sample, and we will do this answer, and we will put the answers here, and answer. Then I will parse the answers, tqdm I'll parse the answers and we will look at the distribution of relevance in our data set. So let's execute that. There could be a problem with parsing, as we know, like it does not necessarily always return what we want. But let's see what happens. So right now I'm putting this on pause and we come back when it finishes. Okay, so it finished only in 3 minutes. Let's take a look at answers. So for example here. So actually it looks like it's parsable JSON in most cases. So I'll just have JSON answers. And then we'll iterate over answer, string answer, in answers. And then we will JSON, we will parse it, JSON load s, we'll parse the string answer, and then we will append the JSON answer. Okay, so it does not always work. Let's see what is the issue. Yeah, so it actually included a code block. So we want to not do this. So we can ask we can add this in prompt that do not output code blocks, because we want to make sure that JSON is parsable. So this is the same prompt we used before. I'll just ask GPT to correct it. Let's correct the. I'll put it on pause and finish and show you the results. Yeah, so what I asked is, let's correct the prompt. I want to make sure the output is always parsable JSON and doesn't include code blocks, but it does not really change anything. So what I do is I'll take the prompt we had before in the previous video when we also were using LLM. So here the prompt was in parsable JSON without using code blocks. This is what I will add here too, but I don't want to recompute it right now. JSON without using code blocks. I don't want to recompute it right now. So what I will do is I will edit it here. We probably also need to know where exactly at which index it is. And so now we also know the ID of this thing. So answers. I'll just correct it manually. So I'll use something like this here. I don't know. Okay, I'll just use this. Okay. So does it work now? Yeah, should work. Now again we have a problem. What is E? Yeah, so I guess we will need to do it a few times. But like we corrected the prompt, so it shouldn't be an issue next time. I hope we do not need to do it too much, because it is getting pretty annoying. No, I don't want to do this like for every record if it's that often. So I'll just rebuild the prompts. So let's see how the prompt looks like now in parsable JSON without using code blocks. Let's see how it works now. Okay, and I'll just redo it one more time. It finished. Hopefully the results are parsable. It looks like that. So it just finished executing that. So that's pretty cool. And now we can turn this into a data frame. Data frame answers. I don't know if I should call it answers or evaluations. Probably evaluations is better. maybe I don't want to rename it, but like answers is more like answer to our question, but here I should call this variable evaluations. Anyways, now we can count relevance. Count, I think it's count values. And count, I don't remember. I think it's count values, but for some reason it does not I don't have autocomplete here. I don't know why. Okay, so maybe describe will work. No. Like why it doesn't show me count values? Value counts. Okay, value counts. Okay, all of them are relevant. Maybe. So like if it's the case, then yeah, it doesn't seem super useful. But still, maybe sometimes there could be irrelevant answers. But also let's execute the second prompt, right? Wait. I think what I did was incorrect, right? So I did not build the yeah, of course, I did not build the prompt, so I just wasted I don't know how many cents on that because I just sent the same thing over and over again, which is weird, right? That's why we have all the cases. In all the cases, it's relevant. So let's see what happens when we redo it. And I'll put it on pause and also change the names. I don't really like that it's answers. I want to call it evaluations. And then we will see what are the results. Okay, it finished executing. I also finished renaming. And we can see that now it looks more like something useful. And we can actually see now what are the examples of non-relevant evaluations. Relevance, non-relevant. And I'll turn it into dictionary. So then we can read the whole thing. Variant records. So let's see. The generate answer discusses a PIT version error related to scikit-learn, which is not directly connected to the regional answer. Focus on Docker build error. So cool. Let's see. This is 4. Sample 4, right? And I think we have df sample, right? Or we can probably read it here. So the question was, what might be the cause of PIP version error in this week's serverless deep learning session? The original answer, this one, and then, yeah. So this is good, right? So now we can actually see the relevant and non-relevant answers. Of course, we probably should do it on a larger sample, but now we get some ideas what's wrong, and with explanation, actually, it makes our job simpler, so we can see what is wrong. Maybe we did not retrieve the answers we needed. Maybe maybe something else is missing, right? So this is quite helpful. Okay, so now we want to do the other thing. So we have 2 prompts, right? The first prompt was when we have original answer and we want to compare original answer and generated answer. But also we can look at the question and generated answer and see if they match. So before I apply it to all the records, I will just yeah, I need to also do it here. I just want to test it before we apply it to all the records. So this is the second prompt, question generated answer. And Where's the LLM? Yeah. Oops. So I'll copy this thing, the entire thing, so next time I don't forget to include prompt. But also in the meantime, I want to show the results of this evaluation. Okay, let's see. Relevant, the generated answer directly addresses the modification made to. What was the question? What modification was made to the median? Okay, so now let's run it for all the data. I think I'll call it evaluation 2. Okay, so let's run it. And also in the meantime, we can do the same thing, right? Parsing JSON evaluation 2, which will do this. And also this part, right? Yeah. I will also save these results, so then and cosine similarity from the previous videos, so then you can also take a look at the files. But probably for this one, since we're doing this on sample, you can do it yourself too, if you of course have an account, OpenAI account. Okay, right now I'm going to pause and come back when it finishes. So it finished and all the answers are parsable, all the evaluation results. So let's look at the results. Again, relevance, was it value counts? So relevant, partly relevant, non-relevant. So let's take a look at the non-relevant results. So you see, even without the original answer, we can see that it's not always relevant. It feels kind of weird to use an LLM to evaluate the results of an LLM, but still, right? We can see that even without the original answer, when we don't compare them, it can detect cases of non-relevant answers. Of course, we still need to take a look at these answers, at these things. Maybe they are. Okay, let's take a look. What command should I use to start Docker daemon on Linux? And the answer, the provide context does not include specific commands to start Docker daemon on Linux. Okay, yeah, so this is not a useful answer. And of course, here we can try to understand what happened, what was the reason. Probably the relevant document was not retrieved. Yeah, so this is a very good use case, a very good example of like when our LLM was able to catch that. And this is something we definitely need to look out for later when we take our system, we deploy it, we start using it on real users. So there will be cases like that, and we want to record these cases in a database somewhere, so then we can analyze this and see. So this is what I wanted to show in this video. And in the next one, we will start with online evaluation, online monitoring too. We will first put everything we did so far in one place. So we'll create a Postgres database. We will take our Streamlit app. We will we'll start putting things to our Postgres database, and then later we add Grafana to it. So then we can also see in real life when our LLM starts generating non-relevant answers and which of the answers are non-relevant. Okay, so that's it for now, and see you soon.